Welcome to tonight's video on Unit 3, Part 1. We're going to talk about how to solve equations that have exponents. There's two types, one where the variable is in the exponent, and that's where we're going to isolate the exponential term and either get the bases the same, or we're going to have to use logarithms. And then the second one is where the variable is the base, and that's where we're going to have to isolate the exponential term and then raise the both sides to the reciprocal power, remembering that there's rules. If you even power both sides, you must check your answers, and if you even root both sides, you must have plus or minus. So for example, number 1, divide by 36. So you get x to the 1/3, or sorry, 1/3 to the x over 5 equals 1/9. So 1/3 to the x over 5 equals 1/3 squared. So then x over 5 equals 2, and x equals 10. And then the next one, divide by 20. So x to the 2/3 equals 1/4. Raise it to the 3/2 power, which means that you make it plus or minus. And 1/4 to the 3/2 power is 1/8. So it's plus or minus 1/8. Number 3, it's to the 1/2 power, so it's 2x minus 1 to the 4/9 times 1/2, so 2/9 equals, and then we have 27 to the 2/27 power. 2x minus 1 to the 2/9 equals, and this is 3 to the 3rd to the 2/3, which means it's 3 squared or 9. So 2x minus 1 to the 2/9 equals 9. Then we can raise it to the reciprocal power. So raise it to the 9/2. So it is 2x minus 1 equals plus or minus, and 9 to the 9/2, that's 3 squared to the 9/2. All right, let me fix something here. 27, it should be to the 2/27 power. That's part of what the problem was here. So then this whole part here. So 27 to the 2/27, that's 3 to the 3rd to the 2/27. So that's 3 to the 2/9. And then you're raising that to the 9/2 power. So when we raise this to the 9/2 power, notice they cancel out. So we get plus or minus 3. So 2x equals 1 plus or minus 3. X equals 1 plus or minus 3 over 2 equals 2 or -1. All right, the next one, we get 1/8 to the 4x plus 10 over 3 power, and that's equal to 64 to the 1/3. I'm going to make them powers of, this could be power of 2, so it's 2 to the -3rd to the 4x plus 10 over 3 equals 2 to the 6/3. So basically you get cancel and you distribute the negative, so it's 2 to the negative 4x minus 10 equals 2 squared. So negative 4x minus 10 equals 2. Negative 4x equals 12. X equals negative 3. Here, this is 2 to the 4th equals 2 to the negative 3rd. So that means 4x minus 8 equals negative 3. 4x equals 5. X equals 5/4. And then here we have x plus 2 to the 2/3 equals 9 to the 1/2. Equals 81 to the 1/2, which is 9. So then you raise it to the 3/2 power, and you get x plus 2 equals plus or minus, and 9 to the 3/2 is 27. So it's negative 2 plus or minus 27, so it's equal to negative 29 or 25. All right, number 7. This one is a quadratic. It's 3 to the 2x minus 6 times 3 to the x minus 27 equals 0. So the factors of negative 27 that add to negative 6 are negative 9 and positive 3. So you have 3 to the x minus 9. 3 to the x plus 3 equals 0. So 3 to the x minus 9 equals 0. 3 to the x plus 3 equals 0. So 3 to the x equals 9, x equals 2. And 3 to the x equals negative 3. That is not possible. So therefore, the only answer is x equals 2. For number 8, you can divide by 2. So you get 10 to the negative x over 3 equals 10. So you can set negative x over 3 equal to 1. So that makes x equals negative 3. Number 9, you can subtract 2. So 3 times 5 to the negative x over 9 equals 15. So then 5 to the negative x over 9 equals 5. So 9 equals 1. So x equals negative 9. Number 10, in order to get 2 times 3, we'll split up 6 into 2 times 3. And then we get 2 to the x plus 4 times 3 to the x plus 4 equals 2 to the 9th times 3 to the t. So then that means x plus 4 has to equal 9, and x plus 4 has to equal t. So x equals 5, and then 5 plus 4 equals t. So that means 9 equals t. So those are the two answers. All right, the next problem, number 11. So 2 to the x equals 3. We cannot make them the same base, so we have to make it a logarithm. So we get x equals log base 2 of 3. Final answer. For number 12, now it's not as simple because there's exponents on both sides, so we have to take the log of both sides. And then roll the exponents. So it's 5x plus 1 times log 10 equals 2 minus 3x times log 3. Log 10 is 1, so it's just 5x plus 1. Distribute the log 3, so you get 2 log 3 minus 3x log 3. And then I want to move everything with a log to one side, everything with an x. So I'll add the 3 log 3 and subtract the 1. And then I factor out the x. And then you can divide. So you get x equals 2 times log 3 minus 1 over 5 plus 3 log 3. Now remember, we want to write this as one log, kind of like we did in number 11. So we have some simplifying to do, like we can roll the exponent back. So it's x equals log of 3 squared, which is 9, minus, and 1, we can make it log 10, because that's the same as 1. 5, we can make it log of 1 and 5 zeros, plus, and then this can be log of 3 to the third, which is 27. And then remember that subtraction means you can divide, so it's log of 9/10 over, and then addition means multiplication, log of 2,700,000. And then the change of base formula, I just want to scroll down here. There we go. Change of base formula says that you can rewrite this as log of the denominator, log base of 2,700,000 of 9/10. And that is your final answer. All right. I hope you enjoyed the video, and we'll see you for Unit 3, Part 2.